All right, everybody, you have those algebra tiles that were in your textbook when you picked it up. Now is the time to cut those out and use them to follow along with this video.
That are red on one side and yellow on the other side. And these are going to represent the quantity of 1 for us. The yellow side is +1, and on the opposite side is the opposite sign, the opposite value, -1. So if I had a number like 2, to represent that number, since it's a positive number, I would need 2 positive 1s. And let's say I wanted to combine or add that to 5. I would need 5 positive 1s. So I would break out 5 yellow tiles. 1, 2, 3, 4, 5. All right, and to add them together, we're just combining them. We're taking the 2, we're combining it with the 5, and we're figuring out what we have all together, which is 1, 2, 3, 4, 5, 6, 7. Hopefully you already knew that. Okay, so when they're all positive, it's very straightforward. It gets more confusing when we bring in negative numbers. So let's do that now. All right, so what if we had something like -3 plus 5? To represent a negative, we're going to need the red side. We're going to flip them over. And since it's a -3, we need 3 negative 1s. -1, 2, 3. So those 3 negative 1s together represent the value -3. Negatives, you should be thinking in your mind, a loss or something you owe. Positives, what you have. So to represent a +5, I'm going to need 5 yellow tiles. Those are my positives. All right, and again, adding is just combining. I'm bringing them together. But I don't have 8. The reason I don't have 8 is because some of these are positive and some of these are negative. If you have $1 and you owe $1, altogether you've got nothing. If you have 1 and you lose 1, altogether nothing. So every time a positive tile and a negative tile come together, they eliminate each other. They become nothing, and we just take them right off the board. All right, so I have another pair, 1 positive, 1 negative. Together, they eliminate each other. They're nothing. Another one, 1 positive, 1 negative. Together, they eliminate each other. They're nothing. I'm left with just positives. So that is my answer, +2, right? All right, let's do another one. What if they're both negative? Like -1 plus -5. So I'm going to use the red side of my tiles. A -1, I just need 1 tile. A -5, I'm going to need 5. Whoops, all negative. 1, 2, 3, 4, 5. -1 plus -5, again, that plus means combine. So we're going to bring them all together. I don't have any yellow tiles. They're all red. So I just need to total up. I've got 1, 2, 3, 4, 5, 6 negative tiles. So my answer is -6. Getting the idea of this? Hopefully it's starting to click with you. So what I'd like to do next is I'm going to put out some problems. Let's try -4 plus 2. I'd like you to pause the video right now, give this a try on your own with your own tiles, and then when you're done, play and see how I answered it and see if you got the right answer. Okay, so as you can see, I used 4 negative tiles for -4. I used 2 positive tiles for +2. That plus tells me that I'm combining everything together. But I've got negatives and positives. So every time I got a positive with a negative, they add up to 0. Since I'm left with red tiles, my answer is a negative answer, -2. How'd you do? Ready to do another one? All right, so our next one is going to be -4 plus -3. Go ahead and pause the video, give it a try. All right, how did you do? -4, 4 negative 1s, -3, 3 negative 1s, all together 7 negative 1s. Since it's all negative, your answer is -7. All right, one more. All right, here's another problem I'd like you to try with the algebra tiles. -7 plus 2. All right, did you come up with 7 negative tiles and 2 positive tiles? We combined them because we're adding. Each one of these positive tiles is going to eliminate one of the negatives, but my answer is going to be negative because I started with more red tiles than yellow. I have 2 less because the 2 yellow tiles took away 2 of the red tiles. So my answer is -5. How'd you do? All right, give this one a try. -25 plus 30. Did anybody count out 25 negative tiles here? Ridiculous. I don't even think I have that many. We don't have time for that. So algebra tiles doesn't work with everything. But that's okay, because even if I don't have time to count out 25 red tiles and 30 yellow tiles, I can imagine them. Can you see them in your mind's eye? 25 red tiles, 30 yellow tiles. These 25 red tiles are going to eliminate 25 of these yellow tiles. Do you see that? When I bring them together one at a time, 25 of these will be taken away. Can you see that my answer is going to be a positive number because I had more yellow tiles than red tiles? In fact, it's going to be +5 because 30 is 5 more than 25. Get the idea? So once you've gotten good at using the algebra tiles, I want you to get good at imagining the algebra tiles so you don't actually have to have them with you all the time. Give it a try. All right, again, too big to use the tiles for. Instead, I'm going to imagine 30 red tiles here and 17 yellow tiles. I'm going to take 17 red tiles away to cancel out these 17 yellow tiles. But I'm going to have more red tiles left because I started with more of them. So that means my answer is going to be negative. This is a little mental math here. The way I would do this one is to say, well, 15 and 15 is 30, but I'm taking 17 away from this 30, so it's going to be 2 less than 15. So -13. Before we can actually start subtracting, we need to learn 2 different ideas. The first one is what a negative means. A positive one we represent with a yellow tile here, and that represents we have 1 of something. The opposite of a positive 1 is a -1. And to represent a -1 using the tiles, we flip the tiles over and we use the red side. And -1 means we've lost 1, we owe 1. It's the opposite of having 1. All right, but what about a -1? So you got to know what to do with this when it comes up, because it will. So what we're going to do is we're going to start with what's in the parentheses, which is a -1. And this negative on the outside is saying take the opposite of whatever you have. Taking the opposite is just flipping it over. So a -1 is the opposite of a -1, which is a +1. And there's no end to the number of negative signs we could put on a 1. We could take the opposite of a -1 if we wanted to, because we're powerful. That means we're going to start with what's in the parentheses. Well, we know a -1 is positive. And this number outside, or this sign, this negative sign, says take the opposite. So we're going to flip it over. And a -1 is equal to a -1. All right. So if we have no negative signs, or we have 2 negative signs, that's a +1. It has a positive value. You'd think all these negative signs would make it negative, but remember, each negative sign, you're just taking the opposite each time. If we have 1 negative sign or 3 negative signs, that's the same thing as a -1. So we're always, if we have more than 1 negative sign, we're going to simplify that down to what it's equal to. Either a positive yellow tile or a negative red tile. All right, let's say we have a subtraction problem. 5 minus 2. All right, in the past, when you were doing more primitive math, you would say, well, I start with 5, that's what I have, and then I'm losing 2, so you take away 2. A lot of people call subtraction take away. This doesn't work that well, believe it or not. I can't bring in tiles to represent this 2, which I'm going to always want to represent every term with tiles. And a lot of people have trouble when they rearrange it. It's really not a very effective way of doing math, but it's very simple and it worked well in elementary school. But now that you're getting up there in the math, you're getting more sophisticated, you need a better way of representing this. And this is what I'm going to have you do. We're going to keep the 5 because definitely we have 5 ones here. But I want something to represent this minus 2. And it turns out that 5 minus 2 is exactly the same thing as combining 5 and a negative 2. Remember what that negative 2 means. Negative 2 means a loss of 2. And isn't that what minus 2 means? Yeah, so by never using this subtraction symbol, every time I see this subtraction symbol, I'm going to want to replace it with adding the opposite. I can use my algebra tiles, and then the technique is exactly the same as in lesson 1. This plus sign means we're combining. If I combine these 5 positives with these 2 negatives, each one of the negatives eliminates one of the positives, and I'm left with 3 positive ones at the end. All right, here's another reason why we don't use subtraction when we're using algebra tiles. This is 4 minus 7. So here's my 4 positive ones. Subtraction says that I should take 7 ones away. Do you see the problem? I don't have 7 ones. I only have 4 ones. So when we're using subtraction, this problem becomes impossible. But when we say, really, this is 4, and I'm combining it, adding it to 7 negative ones, that I can do. I just need 7 red tiles to represent that negative 7. So I've got 2, 4, 6, 7 red tiles. And this plus just means combining. I'm combining these 4 positive ones with these 7 negative ones. Combine them together. And remember, every time a positive and a negative come together, they eliminate each other. They add up to 0. So each one of these 4 yellow tiles is going to nibble away at these red tiles until I'm left with 3 red tiles. Since the tiles are red, my answer is negative, and that makes sense because I had more negatives than positives. And that's why subtraction or takeaway didn't work. I took away all 4 and then I kept going, which means you owe me 3. There is no concept of owing when we use all positive numbers. We need those negative numbers if we're going to end up with a negative answer. Before I do some more examples, and I will, I want to give you a word of warning. There's a lot of teachers who know about this trick, but they don't teach it. And the reason they don't teach it is because they're worried of this. Too many kids will see 3 minus 5 and say, oh, I know, I just change it to addition. And they'll do that. And they'll give you an answer of 8, believe it or not. And these are students who are just following rules and not thinking about what it means. Every single last one of you knows that addition is not the same thing as subtraction, right? Don't ever, ever, ever change subtraction into addition. So this is what I want you to do. If you have 3 minus 5, I want you to rewrite it. I like to write it underneath. So the 3 stays the same. Every time I have a minus sign, I'm not changing it into a plus sign. Did you hear that? I am not changing it into a plus sign. What I am doing is I'm pushing it over. I took this minus 5 and I pushed it over and made a negative 5, and then I'm putting a plus sign in front of that negative 5. Can you remember that? So if I had 8 minus 3, 8 stays the same. Every time I have subtraction, move it on over and put a plus sign in front of it. So 8 minus this 3 is the same thing as 8 plus a negative 3. 3 minus 5 is the same thing as 3 plus a negative 5. Do not ever put a line through that and change it to addition. Even some people do this because it's faster, I know, than rewriting it. But you'd be amazed how many people get in trouble with that. They forget the negative and they changed 8 minus 3 into 8 plus 3 and boom, you're wrong. Some more complicated examples. We have negative 5 minus 2. That minus sign we are going to get rid of before we even bring in our tiles. We have negative 5. We're going to push the minus sign over and put a plus in front of it. I'm not putting a plus in front of the negative 5 because this isn't a minus sign. Does everybody see that? This is already a negative sign. But, and this is why I love this technique, that doesn't hurt anything. I still have negative 5 plus negative 2. This doesn't mean anything, but I didn't end up changing subtraction into addition. So I got 5 negative 1s here to represent my negative 5. And I've got 2 negative 1s here to represent my negative 2. And this plus sign means I'm combining. I'm combining all these negative tiles with these negative tiles, and all together, my answer is negative 7. All right, this is one a lot of students have trouble with. 1 minus a negative 4. Now I said we don't want to leave that minus in there, right? So whenever we have a minus, we're going to push it over. We're going to push everything over. The 1 stays, everything else moves over, and we put a plus in front. And look it! We made a negative 4. That's why I talked to you about that at the beginning of the video. But we know what a negative 4 is. This is a positive 1. A negative 4 is the opposite of 4 negative 1s, right? So there's negative 4. This negative in front means take the opposite. The opposite of 4 negative 1s is 4 positive 1s. So negative 4 is the same thing as positive 4. And so this really complicated looking expression is actually the same thing as 1 plus 4, which is just 5. All right, it is time for you to try them on your own. So here's a problem for you. Negative 2 minus 2. Pause the video, give it a try, let's see what you get. All right, did you rewrite this minus 2? Pushing that minus 2 over, putting a plus in front, and then you can see, oh, this is just negative 2 plus negative 2. When I combine 2 negatives with 2 negatives, I get 4 negatives altogether. Let's try another one. All right, getting trickier. Try negative 8 minus negative 6. Pause the video, give it a try. All right, so you can see that I brought down my negative 8. That stays the same. I push this negative 6 over to the side and put a plus in front. And the negative 6, the opposite of negative 6, is a positive 6. So I've got 8 negative 1s, 6 positive 1s. I know that these 6 positive 1s are going to eliminate 6 of these negative 1s, leaving me with an answer of negative 2. Problem for you to try on your own. Negative 15 minus a negative 25. Now these numbers are going to be too big to use the tiles, but I'd like you to set it up as if you're going to use the tiles and think about what the tiles would look like even if you're not counting them out. See if you can use that to solve this one. All right, so we took this minus a negative 25 and we pushed the whole thing over, making this a negative 25. And we know that negative 25 is just the opposite of negative 25, which is positive 25, which gives us negative 15 plus 25. So I can see I've got 25 positive 1s. I've got 15 negative 1s. I've got more positive than negative, so my answer is going to be positive. These 15 red tiles are going to take away from these 25 yellow tiles. And once I've taken 15 of these away, I'm going to have 10 yellow tiles left. How'd you do? Can we do one more? All right, here is your last practice problem. Negative 32 minus 15. Give it a try. All right, we took this negative or minus 15 and we pushed it over. You can see it's still right here. The minus and the 15 are still right here. And we just put this plus sign in front of it. And the interesting thing is since we have a negative 32 and a negative 15, these are all negative, right? 32 red tiles, 15 red tiles, we're just combining them. So even though there's a minus in this original problem, this is not a subtraction problem. Crazy, huh? That's why the subtraction can be very confusing. Once you've set it up like this, it's perfectly straightforward. You can see I'm just combining a whole bunch of negatives with more negatives, and so my total is going to be negative 47.